That dog up there? Oops, sorry, I was on recording. My bad. That's embarrassing. What? I am DC of the club hand. Good luck, bro. You want some? Maybe someone else should take notes for you. I'm good. I'll try to think. I'm gonna pass. Anyways, yeah, so today we're just multiplying binomials together. Let me make sure I'm actually recording. Yeah, okay, good. So this shouldn't take too long. There's several flavors of, well, a couple of different flavors of things you're going to see. So first, let's just start with the most obvious, and that's going to be problems like this. This question at first was a bit vexing when I asked it last Thursday, but now I think I can't fool you. How many multiplication problems are required? There's 4. So I see that I still vexed you with my question. I go back again to the idea of how many workers are there? 2. How many jobs does each worker have to do? 2. And 2 times 2 is 4. So this should take 4 steps of multiplication and then 1 step of cleaning house. Yes, Sam?
So you know how we're only allowed 1 sheet of notes this year?
I'm aware of this.
Is it front and back?
No. Yeah. Having one side of 1 page of notes is going to force you to make really good notes. Your notes, if you have too many notes, they don't feel as useful. Your notes should consist very concisely of the things that you know you need to work on. And 1 page, 8.5 by 11, 1 side is plenty. Okay, good. Let's get to it. So the first worker is 3x, and I'll color code this for your educational convenience. And so 3x is going to multiply himself by x, and then he's going to multiply himself by 2. There shouldn't be any issues with that. What's 3x times x?
3x squared.
3x squared. And 3x times 2?
5, 6x.
Plus 6x. Good. All right. And then the second worker is -5. And he is going to multiply by x, and then he's going to multiply by 2. What's -5 times x?
-5x.
And then what's -5 times 2?
-3.
Boy. -5 times 2?
Oh.
And so we're ready now to combine like terms. And you don't have to stack them. That whole thing of me showing you how to stack, that's optional. It's just kind of nice. So when we combine them up, we're left with 3x squared. And how many x's? Plus x, because there's 6 minus 5 is still +1. So we have plus 1x and then minus 10. That's it. I'm going to teach you a little acronym, and because I don't want you to leave high school and have, let's say you go on to take like college algebra at LCCC or at UW or North Dakota or Virginia or wherever. I don't want someone ever to bring up the word foil and have you look at them like they're an alien. So I'm going to mention foil here in just a second. So for our next example, I'm going to teach you foil. And it's actually exactly what I just taught you, but it's okay. So let's do 2x minus 3 times, I don't know, -x plus 5. So I don't teach this in Algebra 1 just because I think that people sometimes apply it to too much stuff. Like they start to use the word foil to always just mean multiply things, and it's not true. But in this case, it takes 4 multiplications, right? And there's 4 letters in the word foil, like tinfoil, and they are F, O, I, and L. If you find what I'm about to explain to you if you find it to be completely useless, that's fine. I'm saying I'm doing this all I can say we did. So F stands for first. So we're going to write that down first. And I'm going to color code this now here. And the F standing for the word first means that we're going to multiply the first term in each binomial together. So that's the first times the first. Everyone okay so far? Okay. Does anyone know what O stands for? It actually stands for outer. And so if you look at the problem now for the next like minute or so, think of the problem as um, like four people walking down. Like imagine you saw like four people walking down like a tunnel, and their names are there's 2x, and he's standing next to -3, and he's standing next to -x, and then next to him is +5. You would agree if you saw those four people walking towards you in a tunnel, the ones that are on the outer edge of the tunnel are the 2x and the 5, right? There's just no denying that. So the O stands for outer. Some people say outside. It doesn't matter. So that's outside guy times outside guy. Do you see that? Okay. And you realize here relatively soon, if you haven't already, that we're actually following the exact same steps that we would have anyways. It's just the FOIL is a cute little acronym that some people put on it so they don't forget or something. I don't know how you would, but do you want to guess what the I stands for?
Inner.
Good job. Inner. Very good. And so at this point, I use the same analogy of five guys walking down a tunnel. And obviously, the -3 and the -x, we would agree, are the two guys that are on the inner part of the group, right? They're the inner part of the tunnel. And so for that, the I stands for inner. And of course, L, now the tunnel analogy doesn't work anymore. The tunnel analogy only works for the O and the I. If F stood for first, what do you think L stands for? Last. Very good. And so in the same way that in the same way that the 2x and the -x were the first guys in each binomial, we need to now think about who's the last guy in each binomial. And so L standing for last means to take the -3 times the +5. And again, I would challenge you at this point, in all seriousness, to tell me that that's not exactly what we do anyways. It's the same process. It just, again, the little acronym is something that you'll hear people say like, oh, should I FOIL that? Or, hey, I need you to FOIL that out. And so that obviously this acronym only applies to binomial times binomial, right? It wouldn't make sense for anything else. And so if we follow the red, blue, yellow, green combo here, what is the red combo going to give me? -2x². Very good. And what's the blue combo going to give me? Plus 10x. And what's the yellow combo going to give me? Plus 3x, because they're both negatives. Both of the guys on the inside are negatives, making a positive when we multiply. And then what's is it green? Green combo? Yeah, -15. And then when we add the like terms together, we wind up with a final answer of -2. I hate it when I do that. -2x². And how many x's? Right? And then that is that for now. I'm assuming you're good with this, right? If you could get through binomials and trinomials, then of course you shouldn't struggle with binomials times binomials, because in theory it should be, quote, easier because there's less work to do. You're also today going to see some problems that look like this. And you could look at that and say, whoa, what happened? I thought we were multiplying binomials together. And if you understand the definition of what it means to square something, then you see right through my ruse. That's exactly what it means to square something, is to multiply it by itself. So I'm going to show you there are two ways to do problems like this. I'm going to show you first off exactly what Brandon said, and that is, I'm always amazed at how many questions I get about this. It's like, well, I don't know what to do now. It's like, yes, you do. You always have. You know that to square something means to multiply it by itself. So our kind of backup method, because I'm going to show you a little bit of a different way here in a second, but the backup method is just do what Brandon said. Just multiply it by itself. And then I would challenge you at this point, I dare you to tell me that this is any different than what we just did. It might look different at the beginning, but then you go, oh, it's just one of these, right? And so I'm not going to write out FOIL. We're just going to go through the process. So what is the first one going to be? X to the second. Good. How about the second one? Good. And how about the third one? Just rewrite another -4x. Okay. And the last one? Yes. And then when the time comes, does anyone have any questions, by the way, about where any of those came from?
No.
Okay, I didn't draw my little arrows and color code it, but you get the idea. It's that first and the outer and then the inner and then the last. And so when we add them all together, we wind up with x squared minus 8x plus 16. Done. Okay. What does that take? 30 seconds? We won't probably do any logs in this particular class. No, I don't think that's going to be something that we do. Unless we wind up doing, do you remember those problems last year with the money? Like if you invest $3,800, you don't want to do that?
No.
Oh, you didn't enjoy that?
No.
Okay. I like those problems because they are interesting in the sense that we're talking about money. And I think that generally is something people like to do. Maybe I should teach it to this class and then they can all decide if you're just crazy. No. Okay. So I want to show you a different way to do these problems. What I'm about to teach you the next 2 minutes of this lecture is not something that I require of you. Sam will remember these words from last year, but you're going to hear me say them a lot. Square, square, multiply, double. Sam, you remember that? Mm-hmm. How many times we say that? Yeah, at least. So I'm going to show you a trick that if you don't want to write it out like we did over here, by the way, no shame in writing it out like this, but there's a shorter way to do it. Are you guys ready to follow along? See the x? Square it. What do you get? Nice. You see the -4? Square it. What do you get? What's -4 squared? It is plus 16. Now, notice that I've left a little bit of a space there in the middle. It's not because I forgot how to write or something. Like I don't know how to use my pen. I left a space there because now we're going to take the blue circle times the yellow circle and multiply them together. What do you get? Double what you just said. And then you're done. Because when you take a negative number and square it, it means to multiply it by itself. And a negative times itself is, of course, going to become a positive. You take the blue circle and the gold circle and multiply them together. What do you get? -4x, right? Now double that. What's double -4x? -8x. Let's practice this shortcut method again. And I'm going to put it in quotes up here on the board so you can write it down. Square, square, multiply, double. That can become like our battle cry. Whenever we see parentheses with an exponent of 2, then this will work as long as it's a binomial. Square, square, multiply, double. This is not algebra 2, and so I'm not going to dive deep into all the different instances in which we might use this, but for squaring binomials, it's pretty slick and easy. So let's go again. Ready, set. Here we go. First thing is to square the blue one, and you get x squared. Nice job. Second thing is to square the gold one. What do you get? 36. And you leave a little bit of a space there, right? So that's square, square. What are those last two words? Multiply, double. So take the blue circle and the gold circle and multiply them. What do you get? 6x. Double that. What do you get? And your answer then is x squared plus 12x plus 36. Got it? Let's go again. Square the blue circle. What do you get? You just get x squared. Square the gold circle. What do you get? You get positive 100. Hey, would I be safe in assuming, here's a big brain question for you, that these things that I'm pointing at with red arrows, this is not rhetorical. I need to know if you can answer this. Will those two things always be positive? Yes, they will. And why is that? How are we getting those two blue and gold things? Where do they? Because they're multiplying something by himself. Every single time to get the thing in the front and the thing in the end, you're squaring something. And by definition, when you square something, it ain't going to be negative. So we can take that to the bank. We can say, I will always begin with a positive and a space in the middle. And now multiply blue and gold. What do you get? You get negative 10x. Double that. What do you get? You get negative 20x. Again, no shame in writing it out as x minus 10 times x minus 10. I'm not going to judge. This is just a way quicker way to do it. That's all. Okay. Last thing is I want to see if you guys can do multiplying binomials mentally, and then I'll shut up and get out of the way. So what I want to do here is going against something that you're used to, is I'm going to see if we can multiply binomials without showing any work at all. Some of you will really appreciate that. So here we go. I have no issues if you want to continue to embrace the 4-step multiplication FOIL process. But I just am curious to see, are we able to navigate this and just have the answer pop right out? Yeah. You might be surprised. Here's something I know. And if you disagree with me, I always encourage you respectfully to disagree with me. You should always. You don't have to just buy my garbage because I'm your teacher. I'm going to take the x and I'm going to multiply them. And I know the first part of my answer is x squared. I also know that at some point the -4 and the +7 have to multiply together. And since I know my times tables, I know I can then put a -28. Notice again that I'm putting this odd space in the middle. That's where I'm leaving room for what we shall come to know and love as the middle term. So, ready? In your head. Take the 2 in the middle, multiply them together. What do you get? -4x. You just hold that on one side of your brain. Just store it there for just a split second. -4x. Now take the 2 on the outside and multiply them together. What do you get? You do get 7x. And if you take the -4x and the +7x in your head, what's -4 plus 7? You see how easy that is? You were going to say that, Eli? Nice job. Let's go again. Mental math. What's that, bro? Numbers, you mean? Mm-hmm. That will only work for about the next 30 seconds, just for the record. Now, yes, and you said it, that once I start putting a number in front of the x. Yes. You got this mentally? Ideally, we can get ourselves to a point here where we can start doing these like pretty quick. So what do I know it begins with, my answer? For sure. And what do I know it ends with? -20. Good. So we get that out of the way first. And again, that right there is just this times this and this times this. So you should always take that and run. Now, take the 2 in the middle. What do you get? 10x. Take the 2 on the outside. What do you get? What's 10x minus 2x? Done. Oh, sorry, man. My bad. Because I did these two together, which made 10x. You agree with that? And I'm just trying to show less work here, Colby. I appreciate you asking. And then I took these two, which make, do you agree, -2x? And if you add those two yellow answers together, 10x minus 2x, do you agree that you get 8x? That's it. That's because this is a positive x and this is a -2. And when I multiply them, I get minus or negative, whatever. Make sense? Okay. This time I'm going to put one up and let's see how absolutely fast we can get the answer. All right, let's shoot for like under 5 seconds. Got it? Ready, go. Your 5 seconds is up. Anybody got it? X minus -6x plus 9x. How'd we do on that? I don't want to lose the meat and potatoes, the heart and soul of the lesson. Right now, all I'm doing is just trying to open you up to the possibility that, hey, maybe I can do these faster than writing them down on paper. Maybe my brain is much more powerful than I sometimes give it credit for. Let's walk through it again. What's x times x? Okay, so that one is easy. What's negative 6 times 9? Negative 54. Those should be easy for us being like juniors and seniors in high school. The middle term is the one that comes from doing a little bit extra math, and this will be red and yellow. If you look at your red and your yellow, those are negative 6x plus 9x, positive 3x.
Just do 9 minus 6.
I couldn't care less if you do 9 minus 6 or negative 6 plus 9.
I'm saying, like, just don't pack the X on it. I feel like it'd be a lot easier. What about putting that X on it? Just like,
let's try this one now.
Yeah.
I'm not, again, not telling you that I don't want you to show your work. I'm merely trying to open it up now to you being able to go quicker. So, in about the time it takes me to pour a cup of coffee, you should be able to solve this or simplify this and have it done. What you get, Eli? Nice job, Eli. That's perfect execution. Yep. Let's walk through the steps. So I always would encourage you take the easy stuff first. If your times tables are not easy, well, that's something that you should consider maybe trying to fix. What's 2x times 3x? 6x squared. And what is 5 times negative 4? So that's the part of it where I say, like, we're not allowed to mess that up. But it's the middle part where you have to do a lot of work. You have to multiply, and combine. And your brain can handle all of that at once. Take the 2 in the middle. What do you get? 15x's. Take the 2 on the outside. What do you get? Negative 8. And so if you take the 15 in the middle, you're fine. It happens all the time. If you take the 15 in the middle and the negative 8 from the outside and add them together, what's 15 minus 8? And that's good job there, Eli. That's where that comes from. Okay, let's go again. All right. Okay, good.
all right.
I'm ready if anyone has it.
12x squared.
Yep.
Plus x.
Yep.
Minus 1.
Perfection. Okay. So again, the 12x squared comes from the obvious beginnings multiplied. The minus 1 comes from the obvious ends multiplied. The question we ask over and over again is, where did the middle come from? And that's just, again, over and over again, a result of that red connector makes negative 3x. This red connector makes positive 4x. And we all, of course, know that negative 3 plus 4 is 1. And I just choose not to put 1. So show work if you want to. If you want to get a little bit brave and start trying to mental math some of these things, I would encourage that as well. Any questions? All right.